this is the agenda of my talk. So globally, I will just define what is the big data. Then I will go through the characteristics of the big data V4 as it has been defined by IBM. And then we'll go to defining the different categories of data, and we will have to see that there are divided into three. Then we will talk the main problem that we are facing with the unstructured data. Then I will explain what is the Apache Hadoop, how the Hadoop ecosystem is being defined. Then I will define my contribution in the scheduler of the big data by defining a new algorithm or a new approach for how to improve the scheduler in the big data. Then I will conclude my talk with the conclusion. So I don't know if you are familiar now with this new data unit that we are going to see in the next future, or even that we are now have it every day. I'm sure that you have known the megabyte, the gigabyte, the terabyte, but now we are going further. Okay, we are going to talk about the petabytes, and the CERN Large Hadron Collider generates 1 petabyte per second. I am sure Dr. Mar can give you an idea about that. Okay, so it's a big data that you need to analyze and see. But we are not going to stop that. We are going to talk about the yottabyte, which is 10 to the power 24, and we will go sooner to the brontobyte. So I am sure that this is the first time that you are hearing about this new data unit, but soon we are going to talk about these units. Fine, so this is to show that we are now talking about big data. Okay, so if you have to define it, it's an extremely large data sets that may be analyzed computationally to reveal patterns, trends, and association, especially relating to human behavior and interaction. So actually, the data are not going or coming from just computers or smartphones. They are also coming from Internet of Things. So it might come from the freezer, it might come from your drone, it might come from the alarm, it can come from any device. Okay, so you need to consider that this big amount, okay, how you will treat it. Fine, so IBM has tried to categorize the big data into 4 characteristics, and it's been named the V4. So the V4 are divided into 4, as you see, these 4 Vs. The first one is the volume. Okay, so is the scale of data, and we have already said that we have big quantity of data that we need to treat. Then we have also the second V is the velocity, which is the analysis of streaming data, and this is the most critical part because, as for example, what I said for the petabytes for the large collider within the CERN, you need to treat that data, and that data is coming as streaming. Okay, so you need to treat it as soon as possible. So we have the third V, that is the variety, so different forms of data, and in the next slides I'm going to explain this different type of data, which can be unstructured, structured, or semi-structured. And you need to know that, for example, there are 4 billion hours of video that are watched on YouTube each month. Okay, so it's a big number. How you will store it, how you will treat it, how you will analyze it. This is the biggest question. Okay, then we have the latest one, that is the veracity. Unfortunately, within the data, there is a certain level of uncertainty. Okay, so how you know that the data that you are getting is accurate? Okay, there is no bias, no noise inside it, so you have to treat it, eliminate the noise, and make sure that this data is accurate. So these are the 4 Vs that has been defined by IBM. Okay, and if we go further, as I said before, that the type of data are divided into 3. semi-structured, unstructured, and structured. So for the structured data, we know how to treat it. Okay, it's very easy. The IT has defined a lot of theories. Okay, and most of them they are stored into ERP systems or CRM or large databases or data warehouses. So we know how to treat it, and it's very easy. Semi-structured, okay, it has been some of them they are linked to XML files, email bodies, where it's a mix of unstructured and structured data. But the most difficult part is with the unstructured data. Okay, and all, for example, the audio, video, images, files, archived document, all of these are unstructured. And this is the biggest amount of data that we have to treat in the next coming years. Okay, so this is what I said. It's exploding. So for example, the Internet of Things, the number of wearable devices, number of wireless devices, RFID, the Wi-Fi, all of them are generating data. Okay, I said that regarding the videos, the number of hours of videos watched on YouTube, the tweets within Twitter. And for example, for just, you see this big number, okay, 20 terabytes, okay, which sensor data that are coming from just a flight, okay, that you need to analyze, okay, of course, for checking the accuracy of the different components within the flight. Fine. So as I said, it's exploding, and it's 800% growth in data volume within the next 5 years. So it's very big, and it's growing by 62% faster, and we are expecting that 80% of the global data that we will have all over the world is unstructured by just within the next 2 years. Okay, so it's a big, big amount. Fine. Okay, so one of the things that is going to treat all type of data or all type of big data, this is has been done by the Apache Hadoop. So Apache, for those who didn't know about it, it's an open source foundation, okay, that has created the first open source web server, okay, which is Apache Web Server. Then this consortium has defined also the Apache Hadoop, which is a project that allows, okay, to develop open source, okay, for big data. It's scalable from one computer to big number of computers, and all the nowadays projects that are targeting big data, all of them are using the Apache Hadoop. Fine. So if we are, for example, one university or one company that would like to go for a big data project, so which distribution should we use? Okay, so we have, I have enumerated 3, but they are more than this, okay? But these are the most well-known Hadoop distribution all over the world. We have the famous one, Cloudera, and then Hortonworks and MapR, okay? Fine. Now, of course, we have to use that distribution, but we need to know. Of course, once you are going to interact with the data by itself, so you need to put your hands on the computer and start using a programming language. Okay, there is no other possibility. There are no tools available nowadays that will allow you to do that. So you have to develop programs. So which language you are going to use for developing that? Of course, there is Java still there. Okay, so hopefully our students can go there. We have Python. We have the Scala that has been developed by the EPFL at Lausanne in Switzerland. And we have the R programming language. And the R programming language is considered nowadays of one of the best, okay, programming language for statistics, mathematics, okay, machine learning, everything. You can do whatever you want with the R programming language. And the advantage of this one is that it's open source and supported by all the software editors. Even Microsoft, you know that Microsoft is against open source solutions, but At the end, they have seen the importance of R, and they have their own distribution, okay, of the R, and it's been optimized for allowing to be used on multi-core CPUs, okay? So, yeah, just to show you that. So this is globally the different programming language that can be used. Okay, if you go and talk about the Hadoop, okay, ecosystem, okay, there is a lot of layers, okay? I'm not going to go into details, but I just want to highlight one of the things is that it will depends, okay, what you are going to do with your big data. Is it machine learning? Is it you are going to treat it as database? Is it, are you going to use it as search engine? So as you see in the top layer, okay, you have certain modules, okay, that are dedicated to a specific kind of problems that you are going to treat. So for example, if you want to treat the stream of data, and we said that it's a big one, okay, we can use the Spark that is located on the top, okay. If you are going to use the machine learning, you might use Spark and MapReduce and Mahout. Okay, if you want to use the analytic SQL, you are going to use the Impala. If you want to use the batch processing, you might use the Hive, the Pig, and also the MapReduce. So this is globally the ecosystem. And if we want to talk about the role of the scheduler, okay, within the Hadoop ecosystem, okay, and I just want to highlight one thing, that Hadoop is evolving, and now we are talking about the Hadoop version 2, okay? And I just want to tell you that nowadays, all the biggest company all over the world, they have a big data project using Hadoop. Facebook, okay, Google, Microsoft, Twitter, IBM, all of them, they have a big data project, okay, that are using. Fine, so just I will just close this parenthesis. I just want to highlight one thing, that the role of the scheduler is that you have a cluster, and within the cluster you have a server, but it's the name within let's say the dictionary of big data, it's not a server, it's named the node manager. So the node manager is like the server, is going to distribute the tasks between the data nodes. So the data nodes are just like a client, okay, that are dealing with the servers. And the schedulers will receive, okay, of course, certain things relative to a job that is going to be assigned. And the job is dependent on the type of the module that you are going to use. So this is the idea that comes within my research. So I said that it's better that we will try to make sure that within the scheduler, in order to optimize that, okay, instead of, so because actually the scheduler nowadays, they are just going to receive, okay, the different tasks, okay, and they put them in FIFO, so first in, first order, okay. But we don't know the status, because once you assign the task and put in the FIFO list, okay, after that you don't know the status of your cluster. So you need to know, in order that you optimize the assignment of the task within the scheduler. And this is the things that I have developed here. Okay, so I want to be sure that before I will assign that, I need to know the status of the CPU load, the RAM load, the I/O load, the network load, and also the type of the job. Is it a Spark task? Is it an HBase? Is it Impala? So I have come up with this formula, okay, in order to know and evaluate the resource load, okay? So with this, I will be able to optimize the assignments of the task within the scheduler. And I did some simulations, okay? And this is the algorithm that I came of. So for every data node in the cluster, and here we are talking just about one unique cluster, okay? And so within this one unique cluster that is homogeneous, okay, we will try to make a switch. Is it a Spark module that is being invoked? So I will assign this alpha, beta, and so on. So once I will finish the 4, I will store the array of resource load and I will assign it to the task. Finally, so I have presented a new approach for assigning jobs within the schedulers. And in the future works, so I am going to introduce some machine learning, okay, in order to optimize that and make sure that within, of course, by using artificial neural networks, in order that it will be assigned cleverly the tasks within the jobs, within the scheduler. Thank you so much.